For 3 days, the universe behaved like it had a script. Events so unrelated, so wildly scattered across physics, geology, and astronomy, suddenly aligned with eerie precision. It began quietly, without warning, in the cold pre-dawn hours of September 23. A faint star in Centaurus, invisible to the unaided eye for generations, erupted in a sudden blaze of light. Not a supernova that destroys a star, but a nova, a flash from a white dwarf stealing gas from its companion until fusion ignites like a cosmic detonation. The flare multiplied its brightness almost 100,000 times in a handful of hours, bright enough that even casual observers under dark skies could spot it. For many astronomers, it was the kind of discovery that happens once in a year, if that. No one suspected this was only the opening move. While observatories in Chile and South Africa exchanged frantic confirmations, the rest of the world continued unaware. But beneath the surface of Venezuela, enormous stresses were building along the Oca-Ancon fault zone. By evening, the ground gave way. At 10:21 p.m. local time, a magnitude 6.2 earthquake tore through communities around Men Grande. The rupture was shallow, the shaking violent, and chaos spread through streets and homes. People fled outside as power lines snapped and communication networks flickered. Yet the region had seen earthquakes before. Residents hoped this would be the end of it. It wasn't. Less than 6 hours later, while emergency teams still scrambled to stabilize the injured, the earth shifted again. A magnitude 6.3 quake slammed the same region, as if the fault itself were unraveling in real time. Walls already cracked from the first quake crumbled completely. Aftershocks rippled hour by hour, keeping thousands awake, scared to return indoors. Hospitals ran on emergency power, using tarps and flashlights to treat patients outside. On WhatsApp channels, nurses and volunteers traded updates, organizing scarce supplies in the darkness. The sequence was textbook in some ways. Stress transfer from one segment to the next, but 2 quakes of that magnitude hitting the same region in a single night is almost unheard of. And as Venezuela shook, a different kind of alarm flashed across astronomical networks. Before dawn on September 25, a second star flared into naked eye visibility. This time in Sagittarius. Another white dwarf, another runaway fusion event, but the timing was shocking. 2 naked eye novas within roughly 36 hours. Some astronomers simply refused to believe it until gamma and X-ray satellites confirmed the high-energy signatures. A wave of discovery claims, timestamps, and telescope logs flooded research channels. Nobody could remember the last time the sky produced 2 such eruptions so close together. The tension in observatories rose again when solar physicists chimed in. A coronal mass ejection, an immense blast of charged particles, had erupted from the Sun the previous day. Normally, CMEs are dramatic but predictable. They expand through the solar system like slow-moving shock fronts. But this one, by pure chance, crossed the predicted orbit of one of the rarest visitors in cosmic history, the interstellar comet 3I, Atlas. Only 3 interstellar objects have ever been confirmed entering our solar system. They come from distant stars, carrying chemistry older than the Sun. And out of every direction a CME could have expanded into, this one intersected perfectly with 3I, ATLAS as it raced inward on a retrograde path at more than 60 km per second. Solar particle storms routinely hit ordinary comets, but interstellar ones? Almost never. The odds of this alignment alone were microscopic. The moment researchers laid the timelines over each other, the term, 72-hour stack, began circulating among astronomers, geophysicists, and statisticians. A nickname for a cluster of events so improbable it bordered on surreal. Statistically, each event standing alone was unlikely but understandable. Together? They dropped into probability ranges so low they forced everyone to double-check the math. Some called it Poisson clustering, randomness creating patterns that feel meaningful. But others weren't convinced. Not because of mysticism, but because of sheer scale. 2 naked-eye novas, dual major earthquakes, and a solar storm meeting a cosmic visitor older than our solar system. All inside one window of time so short it might as well have been choreographed. For researchers who had seen decades of data, the stack wasn't just rare. It was historically unique. But the story didn't end there. The 72-hour stack became the spark for a global scientific sprint. Observatories scrambled to capture every photon from the novas. Seismologists mapped every aftershock. Solar scientists recalculated CME propagation. And comet specialists prepared for a once-in-a-generation opportunity to study alien material interacting with our Sun. The universe had just delivered an unplanned, chaotic, and astonishing natural experiment, and scientists were determined not to waste a second of it. As researchers dissected the 3-day cascade, new layers of the story unfolded. For Gabriela Moya, a young astronomer in Chile, the first nova wasn't just data, it was personal. She spent the night switching between remote telescopes, fighting cloud cover, and compensating for power outages that disrupted tracking software. Rumors of a potential outburst had spread through private channels, but she refused to submit anything less than airtight data. When she finally sent her report to the Central Bureau for Astronomical Telegrams, she had barely slept in 2 days. Her detection became the first verified alert, the spark that set off worldwide confirmation. High-resolution spectra from follow-up telescopes revealed expanding shells of gas racing outward at thousands of kilometers per second. Infrared detectors hinted that new dust might already be forming in the wake of the explosion, grains that could someday seed future star systems. Gamma and X-ray satellites recorded hard radiation bursts consistent with thermonuclear runaway on the white dwarf's surface. It was the kind of nova that textbooks could only summarize, but Gabriela had captured it live. Then the second nova detonated. This one triggered a frenzy among professional and amateur observers alike. The sky almost never gifts 2 events of this brightness so close together, and every research group wanted to be first with analysis. Teams cross-checked instruments, scoured archival images, and compiled energy curves that showed the shock front blasting into surrounding gas. Satellites like Fermi and Swift confirmed that the high-energy signatures were real and unmistakable. When the dust settled, there was no doubt. 2 independent white dwarfs had ignited almost back-to-back. At the same time, geologists mapped the Venezuelan quakes with fresh clarity. The first rupture had been shallow and violent. The second occurred deeper but still close enough to cause severe damage. Aftershocks, one reaching 5.8, kept residents on edge. In hospitals, nurses guided patients entirely by flashlight when electricity wavered. Makeshift triage zones sprawled into parking lots. Volunteers hauled water, blankets, and supplies over cracked streets while radio stations broadcast continuous updates. It became a portrait of resilience carved out amid fear. But while the Earth groaned and stars erupted, the Sun added the final thread to the cosmic tapestry. Solar maximum had been brewing, with sunspot numbers climbing and magnetic fields tangling in complex patterns. CMEs had become almost weekly, but this one's trajectory was uncanny. Models showed it sweeping directly through the corridor that 3I, ATLAS would soon occupy. Interstellar comets are scientific jackpots. They carry isotopes, dust, and chemistry formed around alien suns. Even a weak solar storm interacting with such an object could reveal clues about distant planetary systems. 3I, ATLAS itself was on a dramatic path. In early October, it would pass within 0.19 astronomical units of Mars, close enough for orbiters to attempt imaging if conditions cooperated. Later in the month, the brightening of Comet Swan would give skywatchers another target. Then on October 29, 3I, ATLAS would reach perihelion, its closest approach to the Sun. If it survived the heating, December 19 would bring its closest approach to Earth, still far, but perfect for telescopes to study its evolving tail and potential outbursts. For amateur astronomers, this meant months of opportunity. For professionals, it meant the chance to see how material from another star system behaves inside our Sun's magnetic storms. Some predicted tail disconnections. Others expected sudden flares of brightness. Everyone agreed the data would be priceless. By the time December arrived, the 72-hour stack had become a reference point, a symbol of how the universe sometimes compresses chaos into a single moment. 2 novas lighting up the sky, 2 earthquakes reshaping a region, and a solar eruption slamming into one of the rarest objects ever observed. The probabilities were tiny, almost laughably small. Yet the events aligned perfectly, leaving scientists with one compelling truth. Even improbable things don't just happen, they sometimes cluster. Perhaps it was coincidence. Perhaps Poisson statistics simply played out on a cosmic scale. Or perhaps the universe is more interconnected than we realize, with subtle patterns waiting for us to understand. Whatever the explanation, the record stands untouched. In those 72 hours, reality bent toward the improbable. And for anyone watching, it was a reminder that the universe still has surprises, ones that feel planned, even when they aren't. Sometimes nature doesn't just break the rules. It rewrites them. If you'd like, I can also convert these 2 parts into a full 12-minute narration script, expand with sound cues, pacing notes, or voice-over style, short